Okay, so in order to prepare us for the next section of study, which is the chemical and physical properties of the ocean or of seawater, we need to do a little bit of review in terms of the basics with regard to chemistry. So first and foremost, I'm sure you all have heard of matter, and everything in the world is made up of matter. And matter is defined as a physical substance that occupies space and possesses mass. The building blocks of all matter is what we call an atom. So all matter is composed of atoms. And here you can see a cartoon depiction of what an atom would look like if we could see it. Now remember, atoms are super, super tiny. It's even smaller than microscopic level. We need really, really special machinery to be able to see an atom in actuality, in reality. So we use these kind of diagrams to give us an idea of what it would look like if we could actually see it. So all atoms have a central nucleus, and that's that bunch of colored circles in the middle. The blue circles in the middle are known as what we call neutrons, and those particles have no charge, so that's why they're neutral. They are neutrons because they're neutral. Also in the nucleus are protons, and that's the purple spheres, and they're called protons because they have a positive charge. So the nucleus ultimately is a positively charged region of the atom. Even though it has both neutral and positive particles, it's ultimately positively charged. Circling around the neutron are electrons, the negatively charged particles of atoms, and they are constantly circling around the nucleus. In fact, they're never in the same place at the same time as another electron, so that's what this diagram kind of depicts. Those blue rings are the paths that the different electrons would take as they circle the positively charged nucleus. You'll also note that there's what's called electron shells, and that just means there are different levels at which the electrons will circle. So, but that's really in-depth chemistry, and we'll get into that next year for those of you that will be taking chemistry. So for now, just understanding that the atom is essentially a group of particles called the nucleus, which has a positive charge, surrounded by much, much smaller particles known as electrons, which have a negative charge. Okay, so again, the protons and neutrons are much, much bigger than the electrons and actually give the atom most of its weight. So most atoms like to exist in a neutral state, meaning they have the same number of protons and electrons. Therefore, their charge will be neutral. Yeah. So if you have 6 positive charges and 6 negative charges, ultimately they'll cancel each other out and you'll have no net charge. However, atoms also exist as what we call ions, and these are atoms that actually have a positive or negative charge. If an atom has more electrons than protons, it'll ultimately have a negative charge. So, for example, if an atom only had 5 protons but it had 6 electrons, it would be plus, or it would be 1 more negative than it is positive, so it would be a -1 charge. And we call this type of ion a anion. So anion, A-N-I-O-N. If an atom has more protons than electrons, this is a positively charged atom, and we call this a cation. Cation, C-A-T-I-O-N. For example, if an atom had 6 protons but only 5 electrons, it would have a +1 charge, making it a positively charged ion or a cation. Atoms don't just exist alone. They like to group up with other atoms. They can group up with atoms that are the same as them, so oxygen hooking up with an oxygen, or they can group up and form molecules with other atoms like water. You have oxygen and hydrogen getting together. And when they hook up, they form what are called molecules. And molecules are a group of 2 or more atoms or ions that are held together by a chemical bond. There's 2 major types of chemical bonds that connect atoms, and they are ionic bonds and covalent bonds. Ionic bonds are formed by an electrostatic attraction, and we'll talk about that a little bit later. And covalent bonds are formed when 2 atoms actually share an electron, or more than 1 electron. So neither one actually gets the electron, they kind of share it at the same time. So ionic bonds, as I said, are formed by an electrostatic attraction. And an electrostatic attraction is an attraction between opposite charges. So it's a positive and a negative coming together. A great example is sodium chloride. So a sodium ion is positively charged while a chloride ion is negatively charged. Because they have opposing charges, they are attracted to one another, and they easily form what we call an ionic bond, and they stay next to each other due to the attraction of those opposite charges. The other type of bond was a covalent bond, and it's when two atoms share electrons. So the electrons are actually attracted to both nuclei at the same time. So neither one wins the battle. They're both equally struggling to get these electrons with them. However, sometimes one atom might have a stronger attraction for an electron than the other. And in this case, we create what's called a dipole. And a dipole is a molecule that has two separate but equal opposite charges. So you can look at figure A. These are two covalent bonds, okay? And they're non-polar, meaning they do not have a dipole, okay? The electrons are shared equally between the two nuclei. So that little positive, negative charge is seen in the middle. However, when hydrogen and chloride match up, so the first two was hydrogen and chloride, they have an equally strong pull on those electrons. However, when hydrogen and chloride bond, chloride has a little bit stronger pull than the hydrogen. So the center of the positive and negative charge is drawn towards the chloride, making this a polar molecule. Okay, so we call this a polar covalent bond. Polar molecules have a tendency to interact in other ways, specifically through hydrogen bonding. So hydrogen bonding is when the hydrogen molecules within, or the hydrogen atoms within larger molecules interact with other atoms that are not part of the molecule they're part of. So the slightly positive charge of hydrogen is attracted to the slight negative charge on other polar molecules. These connections are not forever. So like ionic bonds, they're pretty solid until we throw some polar molecules in the mix. And covalent bonds are solid unless we do something to separate them. However, hydrogen bonds kind of come and go. So they'll attract for a little while and then get bored and go somewhere else and attract with a different molecule. So these aren't necessarily connections. They're like temporary bonds. So they're temporary interactions between these molecules. Now the polarity and the hydrogen bonding results in different shapes. So molecules take on shapes depending on the types of bonds, the numbers of unbonded electrons, the numbers of shared electrons, whether it's ionic or covalent. So these are just the general shapes you'll see in different molecules. We have linear molecules, we have trigonal planar molecules, so they make like a flat triangle. We have bent molecules, and the bending comes from, again, those polar interactions and the hydrogen bonding. We have trigonal pyramid, again, like the bent. It's bending and twisting because of these other intermolecule interactions, the hydrogen bonding and the polar molecules. And then we have tetrahedral, so actually making a pyramid with a full-on top. Molecules have three general states of matter. They can be either solids, liquids, or gases, and very briefly, the state of matter depends on the arrangement of the molecules inside it. So in a gas, they're very disorganized. They are not connected, and the molecules have complete freedom of motion. They can move wherever they want. And generally, they're really far apart, so there's lots of space between them. With a liquid, the space between them is reduced. So they're much closer together than they would be with gas, but not as close together as they are in a solid. They can move freely in a liquid, but within their container. So gases can go forever, right? Like in this room, they could go outside, they could be in and out of your body, in and out of a room, no problem. However, liquids conform to whatever the shape of the container that they're in. They're not just going to spontaneously overflow and start jumping out of their container. But there still is that level of disorder. So the molecules are kind of just moving around. There is no like set way in which they are set up. However, when we get to a solid, the arrangement is extremely ordered. So it's very structured. It's only going to be one way. The molecules are going to be really tight together, really close together, and essentially actually fixed in position. They're not going to be able to move. So if we think of water as our medium, right, water as a gas is water vapor. Water as a liquid is the water that you know, and water as a solid would be ice. So that wraps up our introduction into the basics of chemistry. Please continue on and finish your quiz at the end of the lesson. Thanks.